Assalamualaikum and hi, my name is Siti Aisyah binti Yusof with student number 2020-897-166. My supervisor is Puan Rani Ibrahim. Welcome to all examiners and viewers for my VIVA presentation with title of the Adsorption of Methylene Blue from leaf of Nypa palm. This is the outline that I will present. For Chapter 1, Introduction consists of many parts. First, the background of study. Methylene blue is a commonly used synthetic cationic dye with a high absorption capacity that is frequently employed in the industrial process of dyeing silk, wool, and cotton. To remove colors from wastewater, absorption is the most recommended approach due to its simplicity, economy, efficiency, and accessibility of a wide range of absorbents. The Nypa palm, or the scientific name is Nypa fruticans, is a unique kind of palm that thrives in brackish water in pond estuaries as shown in Figure 1. According to Ali, 2016, as cited in Shawkiyah, 2020, the methylchromium was successfully absorbed by Nypa leaf absorbent up to 94.41% removal. Therefore, Nypa palm can be considered to be a good natural absorbent for wastewater treatment. Moving on to problem statement, today numerous uses of its production help coastal communities' agricultural fields to grow. For instance, the fruit is used to make local delicacies or alcoholic beverage, while the sap from the tree, which contains 14 to 70% sucrose, is used to make vinegar, toddy, or sugar. As a result, a large quantity of fruit husk is discarded to the environment as waste. The production of useful stuff from Nypa fruticans leaves is not as much as the fruit and sap. Therefore, they were eventually left behind in the river, affecting the aquatic system. The significance of this study is to gain a better understanding of the absorption characteristic and functionality of Nypa fruticans leaf. This study also will lead to widespread usage of Nypa fruticans leaf as a natural absorbent in the chemical chemistry industry. Besides, the health of the aquatic ecology and people that might directly or indirectly affected by Nypa fruticans being left unused in the river can be decreased. Last but not least, for Chapter 1 is the objective of studies. First is to prepare the absorbent powder from Nypa palm leaf. Second is to characterize the batch study effects in terms of concentration, contact time, absorbent dosage, and particle size using FTIR, SEM, and UVs. Third and the last is to study absorption efficiency by isotope model, which are Lamoy and friendly isotope. Chapter 2, Literature Review. A cationic dye from the azo group called methylene blue, or in short form is MB, is frequently used to color cotton, wool, cloth, and silk. Solid sorbents such as MB were used in the absorption process for the removal of dyes. The method has been successfully applied to extract MB from wastewater on a large scale. Many absorbents have been investigated and effectively used to lower dye concentration in aqueous solution. Nypa palm have unique characteristics. Unlike typical palms like the oil palms and coconut, it thrives in brackish water environment where salt and fresh water mix. They can be utilized as a natural or organic absorbent to remove heavy metals from water since they are widely obtainable. Since the characteristic of Nypa palm leaves is similar to coconut leaves, this experiment was carried out based on previous study that has been done by using coconut leaf by Jawad 2016. Chapter 3, the methodology. This is an overview of experimental flow. First is obtaining raw samples. Nypa palm leaves samples was obtained from Kampung Sabak, Kota Baru. And the second is preparation of adsorbent. Nypa palm leaves were dried and grinded until became powder. Third is the batch study experiment. the batch study experiment in terms of particle size, concentration, absorbance dosage, and contact time was studied by UiTM. Fourth is characterization of absorption. The absorption of methylene blue dye before and after were characterized by FTIR and SEM. Last but not least is the absorption study. The absorption efficiency was studied by the Lamoy and Fredlich absorption isotope model, thermodynamic analysis. For Chapter 4, result and discussion, there are three parts. First is the batch study experiment. In terms of effect of particle size, 5 different particle size of 125, 250, 500, 600, and more than 850 nanometer was chosen. Absorption capacity is predicted to improve as the particle size of the adsorbent lowers because the surface area increase. However, as shown in Figure 5, the size 600 nanometer exhibit the greatest degree of equilibrium absorption. Next, for the in terms of effect of concentration, the result shows that the QE value increased gradually from 0.4545 milligram per gram in the presence of 5 ppm MB to a maximum of 2.9591 milligram per gram in the presence of 25 ppm MB. However, in the presence of 30 ppm, it dropped, showing that 25 ppm had the highest absorption effectiveness. In terms of effect of adsorbent dosage, the result shows that as the adsorbent dose increased, QE values decreased, reaching a maximum of 4.9612 mg per gram in the presence of 0.5 gram of NPLP absorbent and a minimum of 0.9546 mg per gram with adsorbent dosage up to 2.5 gram. Increasing the adsorbent dose, on the other hand, reduced the quantity of dye absorption per unit mass of adsorbent. In terms of effect of contact time, the QE value increased from 50 minutes to 70 minutes of contact time, reaching an ideal value of 4.9952 mg per gram, determine the highest possibility of MB ions colliding with the NPLP surface. Nonetheless, after 90 minutes, the QE levels had dropped dramatically to 4.8785 mg per gram. For the second part, the absorption isotope and kinetics. The positive slope of the Lamoye isotope plot and the R2 value, which is 0.9656, indicate that the Lamoye isotope properly describe the MB absorption mechanism on the NPLP absorbent as shown in the figure instead of Fredlich isotope. R2 value of the pseudo second order is 0.6418, higher compared to pseudo first order. This demonstrates that the kinetics of MB absorption onto NPLP absorbent can be described using the second order reaction model. Last but not least, the absorption characterization by FTIR and SEM. The key functional groups in NPLP that may be involved in the absorption process were identified using FTIR analysis. FTIR spectral characteristic of NPLP before and after the absorption of MB can be seen in the figure shown. The sorbent variability was indicated by the distinct characteristic peaks. The primary functional groups involved in absorption were bonded OH group, CH, C-double-bond-C, CO, and C, and stretching. The NPLP material has a rough surface as well as a porous structure. The excellent absorption property of NPLP was due to its surface condition. Because of the deposited MB dye molecules, the surface of the dye-loaded NPLP revealed an uneven, non-porous, and compact structure after MB absorption. Last, Chapter 5, the conclusion. The absorption of methylene blue dye onto powdered Nypa palm leaf has been investigated. Increasing the concentration and contact time increased the quantity of MB dye absorbed up to an optimum point, beyond which the amount of dye absorbed decreased. Increasing the absorbent dosage, on the other hand, reduced the quantity of MB absorbed onto the NPLP absorbent. The particle size in this study differs from previous research in that the smaller the particle, the more MB is absorbed. This might be because of the structure and substance of Nypa palm leaf. According to isotherm and kinetic measurement, the MB dye absorbed on the MPLP surface follows Lamoille isotherm and a second order reaction process. After this, we'll be shown the list of the reference I used. That's all from me. Thank you and have a nice day.